welcome to another lecture from Introductory Statistics. Today we will work on the concept of CDF once again, and today we will be using the CDF, that is capital FX, to compute certain probabilities. So I'll tell you two important uses out here. So let X be a continuous random variable. Say with PDF, lowercase fx as usual, and CDF, the capital FX, okay? Then probability that X is greater than a certain value, A, we know is equal to 1 minus probability X is less than or equal to A, right? So what is this probability X is less than or equal to A? This is nothing but capital F for the value A, right? So one use is this, and the second one, for any two values or two numbers, A and B, probability X is between A and B. What is it? How do you calculate it? It's probability X is less than or equal to B, that is probability till B, minus probability till A. So it turns out to be nothing but capital F at B minus capital F at A. These are the two most important uses of capital F. Of course, there are other things as well. So basically, this is how, when mathematically you are trying to calculate the probabilities, you will use CDF. So let me give you an example here. Suppose the PDF of the magnitude X of a dynamic load on a bridge is given by the following PDF function. Fx is equal to 1 by 8 plus 3 by 8 times x when x is between 0 to 2. Then let's try to find out some probability. Let's find probability that x is between 1 and 1.5. Well, so how you can go about this question? Of course, you can directly find out the probability like this. But what I'm trying to teach you is that how to use CDF. It could be a case that only CDF was given to you. But here I am giving you a PDF so that we can also calculate CDF. So for any number between 0 and 2, capital Fx is minus infinity to x, fy dy, right? So for anything between 0 to 2, it's going to be 0 to 2, 0 to x, sorry. So between any number, between 0 to 2, it's going to be from 0 to x, 1 by 8 plus 3 by 8 y dy. So we will just integrate this, and so we will integrate this and we will get 1 by 8 y plus 3 by 8 y square by 2, and then we have our bounds 0 to x. So hence what we will get is x by 8, because x minus 0 for the variable, plus 3 by 16 x square. Now what is this? This is your capital Fx for any number between 0 to 2. In other words, capital Fx as a function, if you want to mention it, if you want to write it down, or anywhere you will see it as a function, it would be written that since your interval starts at 2, so when x is less than 0, the probability CDF is just 0. When x is between 0 to 2, as for what we figured out, it's going to be x by 8 plus 3 by 16 x square. And when x is greater than 2, it's just going to be 1, nothing else. It will be 1. Okay? If you want to graph it, remember I taught you something about the graphs in the previous class of PDF and CDF. So it's going to be continuous graph. Suppose this is for PDF, and let's create one for CDF here. So here you have 0 to 2. Here you have again 0 to 2. Now, how would your PDF will start from 1 by 8, because when x is 0, your probability turns out to be 1 by 8, and it goes like this in a linear fashion, because that's a linear function, as you can see. Okay. Now, measurements, of course, are subject to measurements. Of course, here it's just an approximation that I'm trying to give you. And when it comes to your CDF graph, what's going to happen is it's going to move. It's going to be 0, 0, 0. And then it's going to move slowly to 1 here. And then after that, it will always be just 1. Okay? So that's how the two graphs will look like. This is for fx and this is for capital Fx. Well, any which ways, we wanted to find out the probability that x is between 1 and 1.5. So that's going to be simply capital F 1.5 minus capital F1. We already have the function, so you just have to put in the function there. 1 by 8, 1.5 plus 3 by 16, 1.5 square minus 1 by 8 plus 1 by 16, or 3 by 16. So it's going to be 1 by 8 into 0.5 plus 3 by 16, 1.5 square minus 1 square. So it will turn out to be something like 19 upon 64. It will turn out to be something like 19 upon 64, or if you're using the calculator, it's going to be 0.297 something. So that's the use of capital F. If you know capital F, you can easily figure out these probabilities. And for example, in this question itself, suppose we want to find out what is the probability that load exceed 1. Then that will be probability x is greater than 1. So it's going to be 1 minus probability x is less than or equal to 1, or in other words, 1 minus capital F at 1. So that is simply 1 minus 1 by 8 plus 3 by 16, which turns out to be 11 upon 16, that is approximately 0.688. That's how we can use the CDF in order to find out the probabilities. I hope this is very much clear to you guys, the concept of CDF now. I'll see you in the next lecture with something more related to the continuous random variables. Thank you so much.